Hi there. For this video, we'll be solving radical equations. So let's immediately dive into some examples as it's easier to explain with dealing with examples. So let's first have the square root of 5x plus 1 equals 6. So how do we solve this one? Well, first recall that a radical is simply if we have a, the square root of a, this one is simply equal to a raised to 1/2. So if our goal is to eliminate the radical, what we do is we square this one. Since by squaring that, we'll have a raised to 2/2. This one cancels and we have a raised to 1 or simply a. Applying the same concept here, we will square both sides. So upon squaring both sides, this one becomes 5x plus 1 on the left side since we have eliminated the radical sign. And on the right side, we'll have 6 squared, which is simply 36. And now we have a linear equation. So what we can do is we can move this to the right side. So we will have 5x equals 36 minus 1. This simplifies to 5x equals 35. And then we can divide 5 both sides to obtain x equals 35 over 5 is 7. And this one out here is the answer. Indeed, if we plug it in to our given, we'll have the square root of 5 times 7 plus 1. This one is equal to the square root of 35 plus 1, which is the square root of 36, which is simply 6, since this one is 6. So take note that it is important to plug in our acquired value in here, since oftentimes when we're dealing with equation, the outcome, we assume that if we have like square root of x squared here, we assume that the outcome is positive negative x in equations. But this is not the case in real examples. So we'll check on to that idea in this next example. Let's have the square root of 2y minus 1 minus y equals -2. So as a tip in solving radical equations, the key is to isolate one of the radicals first. So in this case, if we want to isolate this, what we do is we move this negative y to the right side. So we'll have the square root of 2y minus 1, and that one is equal to y minus 2. Then now we can square both sides and we'll obtain 2y minus 1 on the left side, and on the right side we have a square of a binomial. So by squaring this binomial, we'll have square of the first term, then 2 times the 2 terms, so that will be plus 2 times -2 times y. And on the last term, we'll have the square of negative 2, which is simply positive 4. This middle term simplifies to negative 4y. So we have this. And let's combine the like terms. So we can move this 2y to the right side, and the same for the negative 1. So this becomes 0 equals y squared, and we have negative 4y minus 2y and positive 4 plus 1. Negative 4y minus 2y simplifies to negative 6y, and positive 4 plus 1 simplifies to positive 5. Now, as you can observe, we have now a quadratic equation. So there are various ways to solve this one, but we'll use the factoring method. So by factoring, you can verify that this factors to y minus 5 times y minus 1. Indeed, if we multiply this, we obtain this. If we add them, we obtain this. So by quadratic equations, we know that either we have y minus 5 equals 0 or y minus 1 equals 0. Wherein this y minus 5 equals 0 implies that y is equal to 5, and y minus 1 equals 0 implies that y is equal to 1. Now, before we can conclude that these are the right solutions to this one, let us first check. So let's have at y equals 5. We have the square root of 2 times 5 minus 1 minus 5. This one is equal to the square root of 2 times 5 is 10 minus 1 minus 5. 10 minus 1 out here is 9. So we have the square root of 9 is simply 3 minus 5, which is equal to negative 2. So this matches this one. So we can conclude that y equals 5 is a solution to this problem. How about the other one? Observe that at y equals 1, we have the square root of 2 times 1 minus 1 minus 1. And this one is equal to the square root of 2 times 1 is 2 minus 1, then minus 1 out here. 2 minus 1 is simply 1. And note that when simplified, this is 1 minus 1, which is equal to 0. So it is not equal to this one, not equal to negative 2. So y equals 1 is not a solution to this problem. The reason that it became a solution is because in solving equations, we assume that in this part out here, this also simplifies to negative 1, since that is a secondary root. So completing this one, we'll obtain negative 2, which matches the equation. But that is not how it goes when we check radicals already, since note that this one is equal to square root of 1 is equal to the absolute value of 1. So the outcome must always be positive. That is why it's important to check our acquired possible roots in dealing with radical equations. Let's have this next example. If we have the square root of a plus 4 minus the square root of a minus 1 equals 1. In this one, we have 2 radicals. So again, the key when we have 2 radicals is to isolate 1 first. So we move this 1 to the right side to obtain the square root of a plus 4 is equal to 1 plus the square root of a minus 1. And from here, we apply the square on both sides. So on the left side, we'll have a plus 4. And on the right side, might seem complicated at first, but we just apply the square of a binomial. So the square of the first term is 1 plus 2 times the 2 terms is 2 square root of a minus 1. And the last term is the square root of a minus 1 is a minus 1. So simplifying this, we have 1 out here and negative 1, so that one cancels out. And we are left with this on the right side of the equation. So as you can observe, we are actually left with only 1 radical. So we can simply solve this like how we used to in the previous examples. So we isolate this one. So what we do is we move this a to the left side of the equation to obtain a minus a plus 4 equals 2 square root of a minus 1. Then a minus a is simply 0, or it cancels out. So we have 4 equals 2 square root of a minus 1. Then we divide to both sides to obtain 2 equals the square root of a minus 1. Now we can square both sides. So squaring both sides will obtain 4 equals a minus 1. Then, moving this negative 1 to the left side, we obtain a is equal to 4 plus 1, or that is 5. That is the answer for this. Indeed, if we check, so we can verify out here that we have the square root of 5 plus 4 minus the square root of 5 minus 1. This is equal to the square root of 9 minus the square root of 4. We know that this one is equal to 3 minus 2, or simply 1, which matches the one out here. So this one is indeed correct. Let's have one final example. Let's have the square root of the square root. Oops, let's fix the square root. There. And the square root of b squared minus 5 minus 1 equals 1. Now for this one, we have a radical inside a radical. So how do we solve this? Well, our goal remains the same, and that is to eliminate the radical sign. So we first square this one, and we'll obtain out here the square root of b squared minus 5 minus 1 equals 1 squared is 1. Next, we move this negative 1 to the right side to isolate the radical left out here, and we'll have square root of b squared minus 5 equals 1 plus 1 is 2. And now, this is simply just like how we solved a while ago. So we simply square this one to obtain b squared minus 5 equals 2 squared is 4. Then moving this 4 to the left side, down here, we'll have b squared minus 9 equals 0. By difference of two squares, this factors to b minus 3 times b plus 3 equals 0. So we have, if b minus 3 equals 0, we have b is equal to 3. And if b plus 3 is equal to 0, we have b is equal to negative 3. Last step, we check these roots to our original equation. So we can verify. Let's use a thinner pen so it would fit in our screen. So we have verify out here. We have the square root of 3 squared minus 5 minus 1, and that one is equal to the square root of 9 minus 5 minus 1. 9 minus 5 is 4, and the square root of 4 is 2. So this one is simply square root of 1, or simply 1, which matches this one. So we have b equals 3 is correct, and you can verify by the same process that b equals negative 3 is also correct. So we have found our two answers for this problem. And that is how we solve radical equations. As an exercise, you can work on this example. First, let's have the cube root of z plus 1 equals 2. And next one, a tougher one, we have the cube root of 5c squared plus 5c minus 7 equals c plus 1. Now, as you can observe, these exercises are dealing with cube roots, which we haven't tackled, but the same idea applies. Instead of squaring both sides out here, we get the cube of both sides. So that's a hint. And for the next problem, this one is now harder, but same applies. You get the cube both sides, and then as a hint, let's write it down here. As a hint for this one, note that the cube of a binomial is given by a cubed plus 3a squared b plus 3ab squared plus b cubed. So you'll use this idea on this binomial on the right side, and then solving this one will probably require you some concept on factoring higher order polynomial equations, which I'll probably link around this video for you to use as a guide in solving this one. So that's it for this video. I hope you enjoyed this one, and feel free to comment down below your answers and solutions to these exercises. So that's it, and that's all for this video.